I have a Pico. I have machine learning. Oh, Pico machine learning. Hello and welcome to my channel, Hardware AI. This is another video in Know-How series which focuses solely on a specific feature or technique. And today I will tell you how to use neural networks trained on Edge Impulse platform with new Raspberry Pico 2040. Edge Impulse is a platform that enables developers to easily train and deploy deep learning models on embedded devices. You can watch full introduction of the platform and how to use it in my first video of the series about TinyML. Now, let's jump straight to action. I have Raspberry Pico on my table here, and also I have the Grow Shield for Pico, which makes it convenient to connect various modules to the board during the prototyping phase. We are going to use the model I trained in the first video of the course, the rock paper scissors classifier with light sensor. I shared this project publicly, so you can access it if you follow the link in the description. If you go to Deployment tab here, you'll see a few options available, such as Arduino library, Cube AI, CMSIS pack, and also C++ library. There is no Arduino IDE support for Pico yet, so the only viable option for us is the portable C++ library. Let's choose that option. Enable Ion compiler, build, and download it. Alright, so it is downloaded. It's a zip archive with library inside of it. And on your Linux machine, or in my case, this is the virtual machine with Ubuntu 18.04. First of all, we're going to prepare. This is, I haven't used Raspberry Pico on this machine yet, so I'll install all the necessary dependencies. First of all, I'm going to create a new folder. I'm going to call it Github. Then I'll start by cloning Pico SDK to that folder. Let's do git clone. Basically, for this particular step, you can just follow the guide for SDK Setup. So you'll need to initialize the submodules. Then after that, we will need the examples. We will need to install all the necessary dependencies and the toolchain. So we'll just execute that command. Now, an important step is to set up Pico SDK environmental variable, and you can just do it in the current bash terminal, like that. Although I do suggest you specify the full path, so that basically will be home, Ubuntu, GitHub, Pico SDK. Or if you're going to be using Pico SDK extensively, you can add it to bashrc. Bashrc file, basically the content of it gets executed on whenever you open a new terminal. So we can just copy and paste here. We can use the command line and echo this line to bashrc. Both work. So now, if I open the new terminal, actually I will already have that export command already executed in this new terminal. So after that, we see to GitHub, all right? And then we will need to clone the example inference template that I made available at example standalone inferencing Pico. Again, let's execute another git clone. All right, so that's done. Now, if you remember, we downloaded the C++ library, and now let's copy the library to our virtual machine, to standalone inference in Pico, and then extract here. Okay, we need to put everything except for CMake lists. The 3 folders here. Okay, let's delete that, and we don't zip archive. Great. Well, now let's cd to that folder. Let's create build directory, build, and cd to build directory. All right, and from build directory do cmake 2 dots, which means execute cmake in upper level folder. Sometimes, especially on Ubuntu 18.04, you will get the cmake version error problem if your cmake version is lower than 3.13. In my case, I have 3.10, so we will need to install a newer version of cmake, and you can do it with snap packages, snap cmake Ubuntu. All right, after installing the latest version of cmake, you can execute that command, and it will successfully create make file for you. And then we can just do make comment. After compilation process finishes, you can find the firmware file, .uf2 file. It's called HelloML because it's the name of the project, and the build folder. Now, while simultaneously pressing the boot button here, connect your Pico to computer. In my case, I want to connect to virtual machine, and remember my choice, never ask me again. Now we will have this device appearing as so we'll need to copy that UF2 file to newly appeared storage device called rpi2. Do that. Great. Still want to connect the virtual machine. Remember my choice, and never ask me again. You can now connect to Pico with Arduino IDE serial monitor, or use other serial tools, for example PicoCom. It doesn't matter which tool you use for reading the serial output. Well, I'll use Arduino IDE because I have it installed already. So I'll just choose the ports and open the serial monitor. All right, perfect. Then we will see the following output. It means that the inference is working properly. The code performs inference on the sample data, which you can find here. If you go to raw data of the project I shared publicly, then you will see that this is the first window of paper sample, belongs to paper gesture class. So here are the values, and you will also be able to find exactly the same values if you look inside of main CPP file. All right, so these are the values. So currently, Pico board is performing inference on static data, and we see that it's working properly. Now, you can and probably will say, but I don't want to perform inference on static data. I need to perform inference on my own data. Well, I got you. I wrote another example, and you can access it by switching to another branch in the same repository. So do git checkout light sensor. That's light_sensor. Great. Okay, so we checked out to light sensor branch, and if you look in the source file, you'll see that there is difference here. Basically, before we had the static data, and now in raw feature get data function, actually what we do is in the for loop, we get the data from ping A0 on the expansion board here, and after reading the data, we save that the received data into features array, and then copy it when we perform the inference here. So we will connect the light sensor I have here to ping A0, which is the analog input ping. It's already configured. Now, again, same drill. Basically, we're just going to create a make file. So let's do cd build. Let's remove everything in that directory. And do cmake. And make again. All right, after it finished building, it's the same drill. Basically, now disconnect Pico and connect it again while pressing the boot button. Okay, done. Go to build folder. We have our newly built firmware. So let's put it here. Okay, done. And open the serial monitor again. Now we will see, so now currently Raspberry Pi, Raspberry Pico is getting the data from the actual light sensor here and performs the inference on the data. So I'll try, despite this is another model of the light sensor. The model was trained on a light sensor in wire terminal, so it will not perform very well with a different light sensor, but I can still have a simple demonstration. Like currently I am doing the paper gesture, and that works pretty well. Let me try scissors, this one. And what I remember, scissors, right? Scissors works okay too. It doesn't really work with rock. I'm doing rock now. The model actually worked really good with wire terminal, but for using different light sensor, it needs to have more training data. So don't leave yet, there is more goodies. Since for your own project, you will want to get the data from sensors, and you might have different sensors in mind to use. I also have an example data forwarder. Let me open the GitHub repository. So you can read more about data forwarder in Edge Impulse documentation. Basically, it's a protocol that allows you to send the data to Edge Impulse platform as long as it follows a specific format. Then you can send any data that you want. So basically, the format is really simple. As you see on every line is a data packet that can have many data points, which are separated by a comma or a tab. And then in the end of a data packet, there is a new line character. So you can do it in any environment that you want. They have the Arduino example here, and if you go to my GitHub and git clone example data forwarder Pico, let's close this for now. So I'm gonna go to GitHub, to git clone of the data forwarder example. Great. So same drill. You can have a look at the sources if you'd like. Data forwarder C. It's really simple. basically it is based on ADC example from Pico examples. We just get the ADC reading from pin A0, and then we use printf to send it over USB serial. We do one reading in one specified interval of time. Currently here it's set as 25 milliseconds. So for example, if you want to add more sensors, you need to remove that new line character and then have this instead. You would have print result 1 and then print result 2, and then here you would have the new line character. So that would be sending 3 data points in one packet. Oh, and don't forget to have the comma character here. Okay, so that's correct now. That's, for example, sending 3 different data points from different sensors in one data packet. All right, I'm just going to return it back to the original state, and then it's the same drill. Basically, again, make build dir, and cd there, do cmake, and do make. That's going to be really fast because this is really simple code. All right, so we have the UF2 file in build directory. Now let's take the Pico, disconnect, press button, connect, and copy the UF2. Perfect. And now if you open the serial monitor, you'll be able to see the data printing out. So each data packet only has one data point, which is a single reading from a light sensor. And obviously you can change this example to fit your sensor and your application. Finally, for the most curious of you, a short explanation on how I created this inference example for Pico, because originally it's a very new board and there was no examples on the internet on how to use edge impulse with Pico board. So that might be useful for you if you're if you want to use edge impulse on another boards that are not supported yet. So first of all, I modified the CMake lists. What I did here is that I took all of these directories that are necessary for edge impulse, like the modal data, the folders for classifier, for CMSIS. So all this data I actually took from another board, CMake lists file. And what I did, I also added the Pico SDK import, Pico SDK init. These lines are for enabling the output on USB and disabling the output on UART. And then there is the last line here that builds UF2 file. So basically creating CMake lists, that's the first step. And also what I had to do is to add EI classifier porting file, which is present in Edge Impulse Inferencing SDK. And basically here we just have a few functions, such as EI retimer, MS, milliseconds, US, that would be microseconds. And also we have the printf function, malloc, calloc, and free. Basically what I had to do is just to change these function placeholders to the functions from Pico SDK. So for example, this is how we, for example, in case with Arduino, this read timer ms millisecond would be just return millis, would look something like that on Arduino. But we don't have millis function on Raspberry Pico, so instead we're going to use this, and you can find this information usually in documentation for your board's SDK. And then if you search through this documentation, you will be able to find the functions that you need. For example, if we look for that 2ms since boot, yep, I'll be able to find it here. Convert the time step into number of milliseconds since boot. So basically, having these files, after that, I took the content of the inference, of the classifier inference from Arduino. Basically, when you download your trained model as an Arduino library, as I did here, go to examples, and there is this is the library I downloaded for another video. There's static buffer example, which performs inference on the data with the classifier model. Basically, I just copied the content of this file and changed all the Arduino functions to their equivalent with Pico SDK. For example, you can see that in Arduino we use delay, and for Pico SDK we are using sleep milliseconds. So just different functions, but different names of the functions, but their usage, their purpose is the same. If I can do it, so can you. You don't need any external hardware to run these examples. So if you already got your Pico, try it out. If you haven't, you can buy it on Seed Studio website together with the expansion board, and it will come to you in this nice package. Good luck, and I'll see you next time.